Hey everyone, today on Workshop Quick Takes, the Yelangu smartphone camera rig purchased via Amazon.com. What's hot? Solid feel and lightweight build for just $30 USD. High quality phone mount using a fine pitch screw, 2 hot shoe style adapters for accessorizing, easily reconfigured for pistol group use, and for not, it is too narrow for common device configurations. Our solution? Power tools. Oh yeah. Well, one of my ongoing goals to improve my camera technique is to get a few gadgets. Also because I like gadgets, so why not have a couple? This here is a Yelangu camera grip designed for mobile devices. You can see here that it has a couple plastic grips, and it's got these cross pieces. There's a couple hot shoe adapters here for microphones, you know, lights, whatever. And then this nice little, very nice actually, machined clamp for the phone or a mini tablet, whatever fits in there. And I like it, but as I got it out and started using it, I noticed a little problem. I am currently working with a couple old Google Pixels. So here's one. And when I snap it in here, in order to avoid the volume control, this is about the farthest position I can have it, right there. So that's fine, except my fingers are already bumping up against the edge of the phone there, which can cause, you know, jiggling and whatever, and just makes it uncomfortable to hold. But if I go any farther over, then I'm on top of the volume control. Well, that's not very helpful. To make matters worse, I just picked up this Rode video mic. So let's suppose I'm working with this. And I've got it screwed into the hot shoe adapter here, which is great. And it's one of the reasons why I'm still using these old Google Pixels, or at some point maybe I'll get a 3A, is the fact that it has the microphone jack on it. And you know, I'm sorry to all of you Bluetooth fans, but Bluetooth isn't perfect. It hitches,
It sometimes lags, it disconnects.
a wired connection is still the most reliable way to get a high quality mic attached to something, period. So there we go. Now look what I've got. Yeah, how am I gonna hold on to that when I've got the jack jammed right against the side there? So I got to looking at how this is constructed and noticed that this screw that's holding this piece in is very nicely positioned right here in the dead middle, but there's a lot of extra space. They didn't cut this piece right up to the screw hole, so maybe I could add a couple other mounting points that would accommodate this device as well as future ones that maybe need a bit of an offset. So let's take a look at the feasibility of that real quick. What do we have underneath here? Okay, here's the piece that's being held on by this. And this is simply a 1/4-20 thread, I think, same as a camera mount, with a very large countersink. Hey, it's pretty easy to add a couple more holes like that here and here, and maybe that offset will give me some additional working room. So let's go for it. I'm going to start with a ruler. And I will just try and roughly, this isn't going to be perfect, but it should look pretty nice. I'm going to try and roughly center the 9-inch mark there on the hole, and then looking at it, it's about 1, 2, 3, 4/8, yeah, almost a 1/2 inch wide there at the maximum extent of the countersink. So if I come out here to, let's say, right about there, and make sure I still have a 1/4 inch of clearance so I don't get my holes overlapping, I think right there is a good spot, and right there. So I've got my 2 little marks. I don't know if they're really visible or not. Let's try refocusing that. Okay, got 2 very slight little marks, one there and one there, that I'm going to use as the starting points for drilling. This is a very simple operation. Almost anyone can do at home with basic parts. You do need a drill, you do need a couple bits, and you need a countersink bit, but all of that stuff is fairly cheap. If I wanted to go wild, I could remove these 2, take this piece off, put a protective little sleeve on it, and then clamp that sleeve into the vise and give myself some extra working space. But I want to try and show it how you might be able to do this at home. So here's my drill with a 1/16 bit installed. It's one of the smallest you can get for a conventional drill. If you have any sort of power drill at home, you can buy one of these. So let's just try and find a couple of my tap points there and see if I can get the bit started on it neatly. Okay, good. I did wander just a little bit there, but the nice thing here is this material is aluminum, as I thought. So if it was steel, it would be a pain to machine, but aluminum is soft enough that almost anybody can work with it. So there's going to be one of my start points. And there's going to be the second one. Now let's remeasure and just make sure they came out where I think they did, because I see I got a little bit of offset there that's not entirely desirable. Actually, that's pretty good. And since, again, this is aluminum, I think I need to push this one just slightly, which I can do by hitting it at a slight angle. Okay, good. Now what I'm going to do, since I've had my two start points, I've remeasured them, I like where they are, is I'm going to go ahead and just finish drilling those all the way through. One thing when working with aluminum is you tend to fill up your bit with a lot of kerf. Clean that out periodically, or it'll start fouling the hole as you try to drill it. You want to work carefully when you're doing this, because if your bit starts jumping around when you're making that initial hole, it'll scratch up this nice powder coating they've got on here. Alright, there we go. That's one pilot hole. Do the same thing twice, make sure I got my bit cleaned off again. Be careful because that can get hot, obviously. Work patiently. One mistake that people make, especially beginners, is they get in a hurry. So they start jamming this thing around trying to make it go faster. These bits break off pretty easily, and this bit is a good deal harder than the aluminum I'm drilling into. If I break this bit off in my hole, I've probably lost that hole. I'll have to start with an offset again. When drilling through thick material or using a thick bit, one thing you can also do is lubricate the bit. There are mineral and machining oils that work really well for that, but if you're just trying to do it off the cuff, WD-40 works fine as well. Just need to clean the residue off when you're done, of course. Okay. So there are my two pilot holes. When you need to drill large holes, start with small holes, always. So my next one, I'm not going to step it up to the final hole size because again, I'd start gouging it out. I'm going to go to a 3/32. Since this is a 1/4 20 screw, that's a standard thread used for camera mounting from old times. It's not metric. You'll notice that this 1/4 inch bit goes through the hole with a little bit of play, so that hole there is slightly larger than 1/4. The other thing I see with this hole is that the countersink goes almost all the way down to the other end there. We'll work with that in a minute. But for now, I'm going to drill and get a second larger hole going through the pilot. And step it up again to a 3/16. Another nice thing about working with aluminum as opposed to steel is these little bits of aluminum are soft. They usually won't jab your skin, and they tend to stay in fairly large fragments. When you're working with steel, if you've never worked with steel before, these fragments will tend to be small and very pokey. They get in your skin, make life very unpleasant. So now I've drilled out this hole all the way to 3/16. What am I going to do next? I think at this point I will go ahead and drill it out with a 1/4. Ooh. That's another reason why you work with small bits and then step up to larger ones. Sometimes the larger ones will grab like that. I should have been securing that better. Okay. Another thing that'll help is to actually use a corded drill with a lot of torque, or at least a very good battery operated drill. If you don't have one of those handy, you work with what you got. But a drill with higher torque will actually tear into the material more efficiently rather than grabbing it and twisting it like that. Okay, so there it is. I've now got two fresh 1/4 inch holes in my assembly here, as you can see. And as is typical, when you drill a hole from one side, you usually end up with some little bits and pieces on the other that we'll have to clean up somehow. Since this is aluminum, cleaning those up will be fairly easy, but let's go ahead and make the countersink from this side. I have two possible options how we're going to do this. This here is a fairly high quality countersink bit. You get these at like Home Depot. This here is a lower quality set from Harbor Freight, but one thing I do like about these is they have a slightly shallower taper, so I'm going to figure out which one of these matches that hole best and then try and replicate it. Probably going to be either this one, and that is a pretty nice fit, or this one, and actually that one's also a very good fit, and I think I want to work with this one because it has a little bit better bite than this cheap one. Now when I say cheap, we're not talking a huge difference. I think you can get one of these for about $6-7, and periodically, you dull them out, you just replace them. But let's see how it does. Pretty good. I think on the side. I like what that's doing, but I can already feel that it's heating up. So what I'm going to do, even though it will make a bit of a mess, is put a little WD-40 on this. And so I'm just going to periodically lightly lubricate this bit slightly. Now watch how much more efficiently this cuts out. Look at that. There's a reason machine shops are full of oil. It's because even when you have two cutting surfaces going past each other like this, they'll cut a lot more efficiently if they're lubricated. Or a cutting surface past a material, I should say, a working material. Okay. I'm going to relubricate and continue on the second hole just to see how that works out. Getting pretty close. Just to show what that's starting to look like, let's just try test fitting the screw and see how it fits in there. See, it doesn't set all the way down yet. We are going to need to countersink this to the same width as that one, but we're getting closer. Mostly it just takes patience. This is just like drilling the initial tap hole. You work too fast and you'll mash the material and bend the piece of work that you're having in front of you instead of getting a nice clean cut. Alright, let's check our fitment there. I think we're pretty much there. It's mainly now this gasket that's having a little trouble. So there's a couple things I'm going to do to try and deal with that. Okay. Now let's see what we can do to clean that up a bit. I believe I actually will take the Harbor Freight bit now and just use it to clean the perimeter of the hole. So we're going to take this, oil that a bit, WD-40. Then as a final step, since this is aluminum, I can actually take a steel blade, just gently work it around the edge here to take off this lip that's formed. This is a fresh sharp blade, so if I go crazy, I can actually gouge back into the aluminum with it. I don't want to do that. I do just want to get a nice clean little lip there, so that there's no possibility of sharp fragments or whatever coming off of it and injuring me later when I'm trying to change gear. Yeah, that's pretty nice looking. Okay. It's getting close to where we want it. Now I just got to decide what I'm going to do to enlarge that hole, because that is smaller than 5/16 and I don't have a metric bit set that might have something in between. The other thing I can do though is remove this hot shoe adapter, and fortunately this one's easy because it has these dials. I don't have to undo the hex screw. It's down below. Okay, I'm just gonna have to do this or I'll never get it tight enough. I'm going in with the 5/16 bit. And I'm going to do it from the top here. A little bit larger than what I wanted in the first place, but it will work. And then I'm going to take the knife from this side and just make sure I didn't leave any burrs on the inside of the hole that I was cutting through. I am going to mill these holes very slightly using the countersink bit. Okay, so unless I miss my guess, this should be a pretty good fit. Looks like. Now, one thing I will lose by using one of these side positions is this in here has a very nicely milled little insert here that keeps this thing from rotating once it's secured. I won't have that when I'm connected to one of these. So these ones will have the potential to rotate, but let's just see if I can at least get a basic mount here. Yeah, perfect. That's going to be a pretty good fit. So yeah, it's almost completely flush, so that works out nicely. I really don't want to try and dig that hole out any deeper, or I'm just going to make a mess of it. That's about as exact as I'm going to get with the tools I'm using, and unless you have access to a machine shop, your results probably won't turn out much better than that either. Let's go ahead and reattach the top plate here with the hot shoe adapters. Okay, well there we are. Now let's see if that solved the problem we were originally targeting. Here's the phone. And I'm mount it the same way again, making sure I'm just clearing the volume control. It's a pretty solid fit. My fingers are just clearing the phone on this side. And let's go ahead and hot shoe the mic on. And plug that sucker in. Hey, look at that. It works, and we gave ourselves a spare mounting hole on this side just in case for some reason I ever had to turn the phone over and run it the other way, or work with a different device that had a different button layout. So there we go. I've got the phone mounted. I've got the mic in the hot shoe. I've got the mic plugged into the phone, and my hand's just cleared on both sides, which means it is now a usable camera rig. Oh, quickly, you there, a word. What are your thoughts on this situation? Has anyone seen my phone?